Dear students, in this video we are going to see linear congruence and Chinese remainder theorem. Okay, we will start with an example. Find GCD of 41 and 12 and then express that GCD as a linear combination of 41 and 12. Okay. Now already we have seen Euclidean algorithm in the previous video. We will apply that Euclidean algorithm to find GCD. Okay, so that here first we take the bigger number, that is 41, the smaller number is 12. So we divide the bigger number by the smaller number. So that I write 41 is equal to 3 multiplied 12 plus the remainder is 5. Then for the next step I take 12 and 5. So that 12 is equal to 2 multiply 5 plus 2, remainder is 2. Now for the next step I take 5 and 2. So 5 is equal to 2 multiply 2 plus 1. 1 is the remainder. So now I can take this 2 and 1 for the next step. So 2 is equal to 2 multiply 1 plus 0. Okay, here remainder is 0. So we can stop the process. What is the previous non-zero remainder? That is 1. This is the GCD. This is the GCD of 41 and 12. Okay. Now see, in another way we can find the GCD. See, by argument we can conclude that the divisors of 41 is nothing but 1 and 41. Okay, and 41 does not divide 12, so that we can write the GCD of 41 and 12 is 1. Okay, then how to write the linear combination of 1? We can write as x multiply 41 plus y multiply 12. This is a linear combination of 41 and 12. Okay. So now how to find x and y? That is not easy. That's difficult. But by applying the Euclidean algorithm, we can do the back substitution from this. Then we can write the GCD of 41 and 12 as a linear combination of 41 and 12. Let's see that. Okay. Now see, here I can write the remainder 1 as 5 minus 2 multiply 2. See, from this step I can write 1 is equal to 5 minus 5 minus 2 into 2. I am going to replace this from right side to left side. So I can write 1 is equal to 5 minus 2 multiply 2. Okay. Now I can rewrite from this equation the remainder 2 is equal to 12 minus 2 into 5. Similarly, I can rewrite this remainder 5 is equal to 41 minus 3 into 12. Okay. Now, see, elimination of remainders gives the linear combination of 41 and 12. Okay, how? See, start from here. 1. 1 is equal to 5 minus 2 into 2. Okay, this is first step. Then see, I have the remainder 2 as 12 minus 2 into 5. So we substitute this value for this 2. Okay, now so that 5 minus 2 multiply this 2 is replaced by 12 minus 2 into 5. So that I can write 12 minus 2 into 5 here. Okay. Now you multiply 2 here. So 2 into 12. Now minus 2 into 5, so that plus 4 into 5. Okay, so now already we have 1 5. You see here carefully, 5 here, minus 2 is plus 4 into 5 is nothing but 4 times 5. I have here 1 time 5, so that is 5 times 5. Here the remaining is minus 2 times 12, that is here. Okay, and that is here. Now, see here, 5 is equal to 41 minus 3 into 12. So that I can write here for this 5, you see, for this 5, I can write 41 minus 3 into 12. So that 5 multiply 41, here multiply this and this, minus 15 into 12, here minus 2 into 12. So minus 15 and minus 2. So minus 17 multiply 12. So now what we are getting? the GCD of 41 and 12 is 1 is equal to the linear combination of 41 and 12. That is what we require in this question. So this is the way how to write the GCD of any two numbers as a linear combination of the two numbers. Okay, by applying the Euclidean algorithm and doing the back substitution, we can write. That's it. Okay, now we see here. What is linear congruence? You see, a linear congruence is of the form AX congruent B modulo M, where A, B, M are integers and X is a variable. Okay. To solve this linear congruence, to find all integers that satisfy this congruence. Okay. For example, what is the solution of this? This you try it. Okay. You try how to find this X. Okay. But we learn about the inverse, how to find inverse. Okay. You see this example. Find inverse of 9 modulo 23. Okay. How to find inverse? We'll start from Euclidean algorithm. Okay. Now, first we will find the GCD of 23 and 9. Okay. Now, here the bigger number is 23, smaller number is 9. So that, see here 23. So here we divide 23 by 9. So 23 is equal to 9 multiplied 2 plus 5. Remainder is 5. Okay. Now, again, for the next step, you take this 9 and 5. So 9 is equal to 5 multiply 1 plus remainder is 4. For next step, you take this 5 and 4. So 5 is equal to 4 multiply 1 plus 1. Remainder is 1. Now take 4 and 1. So 4 is equal to 1 multiply 4 plus 0. So here remainder is 0. So we can stop here. Now, what is the last non-zero remainder? That is 1. That is the GCD of 23 and 9. So what is the GCD? The GCD is 1. That is here we are writing. So GCD of 23 and 9 is 1. Okay. Now we know that I can write this remainder 1 is equal to 5 minus 4 into 1. See, I can rewrite this equation as 1 is equal to 5 minus 4 multiply 1. Similarly, from here 4 is equal to 9. See, I write this term into the left side. So 9 minus 5 into 1. Similarly, I can do this here. Okay. Now we know that what is the GCD of 23 and 9? That is 1. So now start from here, which means you take this equation. It is 1 is equal to 5 minus 4 into 1. See, that's what here first. Here actually 4 into 1 we have. Okay. So now for 4, what I can write? For 4, that is 9 minus 5 into 1. That is here. See, 5 minus, for 4 I write 9 minus 5. Now here what I do, this minus you multiply, minus 9, this minus into minus plus 5. Okay, so plus 5 means here 5 plus 5, 10, that is 2 times 5. Okay, so that I am writing like this. Okay, now this is equal to, see here, what is the value of 5? 23 minus 9 into 2. So here for 5, I can write 23 minus 9 into 2. Multiply this 2, then minus 9. So that I can simplify this is equal to 23 multiply 2 minus 9 times 5. Okay. So now this is the linear combination of 23 and 9. Okay. So now you see here, the last equation implies that you see here. See, 1 is equal, actually here we have 1. Okay. 1 is equal to 23 multiply 2 minus 9 into 5. Okay. So I take this one side, that is 9 into minus 5 is equal to this one. Then 23 into 2 I write with this one. So that is here. Okay. Which means what? This equation says that, think that 9 multiply minus 5. You see 9 multiply minus 5 congruent to this 1 modulo 23. Okay, how we can write? Whether it is true or false, we don't know. Okay, we will check it. You see here, already we have seen last week video, A congruent be modulo n means I have to find the difference of these two. Okay, see here 9 into minus 5 how much? That is minus 45. Okay, then here this is the value 1, so you write here find the difference, so that is minus 45 minus 1, which means minus 46. Minus 46 is nothing but I can write minus 2 multiply 23. Okay, here 23 is the modulo. Okay, so you see here when we can say that this congruence is valid 1. See, you take this value and this value, find the difference, and then here to check whether we can write that difference is a product of 23. Okay, see, yes, minus 45, this value is minus 45, then this is 1, so minus 1. So to find the difference, so the difference is minus 46, that is equal to, we can write this minus 46 as a product of 23. Okay, so here this is minus 2 is satisfying. You see here actually this is already we have derived by Euclidean algorithm. So see, whenever, listen here, whenever you write the GCD of any two numbers as a linear combination of the two numbers, then I can form, see, I can write from that linear combination, I can conclude that I can write, see, you can write, see, this GCD here, and then see what is given, that modulo, what is given, that modulo is 23, you can write here in the congruent equation. Then the remaining, that is see here 9 times minus 5, you can write it here. See, whenever you write the GCD of two numbers as a linear combination of the two numbers, then I can write this congruence equation from that linear combination of the two numbers. Okay, so I can write this because we have verified here. Yes, this is true for all the questions. Okay, now so that I can say, see here, if I get here is 1. Okay, if suppose I get the GCD is 1, and suppose I write this linear congruence, suppose I write this congruence equation, then I can say that, see, the inverse of 9, the inverse of 9 is nothing but what is here, this is called the inverse of 9. Oh, so now I can say that inverse of 9 modulo 23 is nothing but minus 5. Okay, that is our question. So what is your question? Find inverse of 9 modulo 23. So that first you apply the Euclidean algorithm, and then you write the reminders like this. Then by back substitution you can write that GCD as a linear combination of the two numbers. And finally, after writing this, I can write this congruence equation. Okay, from this equation, see here, it's very important, you have to see here the GCD is 1. Yes, if GCD is 1, then you can go here, this number is 9 is given in the question. We are looking for the inverse of this 9, that is nothing but what is here next to that in the product, that is minus 5 is the inverse of 9. Okay, modulo 23. So that our answer is minus 5 is an inverse of 9 modulo 23. That's it. So we will see the continuation of this video in the next